Problem 720. Planets go around the Sun in elliptical orbits. The highly exaggerated diagram shown below shows a portion of such an orbit and the force on the planet at one position along that orbit. The planet is moving to the right. F parallel and F perpendicular are components of the force tangential and perpendicular or normal to the orbit. The work they do is work parallel and work perpendicular. At the position shown, and we want to find out how these work relate to this action. Well, if we look at this force, we have, as they mentioned, two components of this force. We have a component that is perpendicular, which is normal to the orbit, and we have a component that is parallel. And ultimately, this object is moving with a displacement along the orbit, like this. Well, we know that in general, work is equal to the dot product between the force and the displacement, which is the force times the magnitude of the displacement times the cosine of the angle between these two vectors. Well, in this case, if we look at the work perpendicular, that's going to be the force perpendicular dotted with the displacement, and that is going to be equal to that force, at least the magnitude of it, the displacement times the cosine of 90 degrees. Cosine of 90 degrees is in fact 0. So there's going to be no work done by the perpendicular force. Work done by the parallel force is going to be the parallel force dotted with the displacement, which would be the magnitude of the parallel force times the magnitude of the displacement, cosine of 180 degrees. And the cosine of 180 degrees is a -1. So this work is going to be equal to the negative magnitude of the parallel force times the magnitude of the displacement along the orbit. So this would be negative work. In fact, it's going to be acting to slow the projectile down, or the planet down. So one force, the perpendicular force, does no work, and the other force, the parallel force, acts to slow the planet down. And that's our answer.